This video will demonstrate the DTI UHF RFID IO-Link enabled antennas from IFM. I have them connected to an IFM IO-Link master and will be reading the TID from a tag. The tag I'll be using is the E80413 and it has a memory location, the tag identifier, and it is 8 bytes long. Notice this datasheet is incorrect. This should say 64 bits or 8 bytes. We'll be integrating this into an Allen Bradley PLC. So I have an AL1322 IFM IO-Link master integrated over Ethernet IP to the PLC, and it is communicating. There's an add-on instruction written so that we can read the TID of the tag. So far I've given an instance name. I've imported the controller input and output arrays. I've given an IO-Link master name, and I'm on port number 1 of the IO-Link master. We can see the vendor ID and the device ID is cyclic data coming in from the DTI to identify that it's from IFM and the family of sensors with the 1418 value here. By default, we're in the single EPC mode, so the data that we're getting right now from the reader is the single EPC data. So a tag is present in front of the reader, and we can see that I have a EPC length of 16 bytes with an RSSI value. What I need to do now is configure the sensor, or the DTI, so that we can read the TID value. That's done in the configuration settings above. The configuration settings above start with the power, read, and the write. This is a range so that we create the field of view in front of the antenna so that we can detect a tag. So by default we have a value of 23 for the read and write. The value range is from 10 to 23 for the read and write, and we have several input parameters that we can put in here. You can reference any of the values in the manual to see what the ranges are for the parameters, or you can also click on the 3 dots and the descriptions of the tags have been imported. So for the power, the read, the write, if we take a look at that, we can see that it is a value range of 10 to 23 and a description of what the tag is. For my purposes, I'm going to tone this down so I don't see too far out into the field of view, because this does have quite a bit of range to it. The RSSI value is the signal strength coming from the reader. In this case, you may have multiple tags in front of the reader, and we can detect just one tag as long as we create a window. For instance, we can see here my value is changing. Let's say I don't want to see anything greater than a -40 value. So I may have multiple tags in front of the reader, but in this application and for this add-on instruction, this is for single tag applications. So we do want to ensure that we are only reading one tag at a time. We can do that with a combination of adjusting the power and the RSSI values. The detection mode, this is in the manual. We're going to leave it to 0. This is the fastest detection mode. We do have some other settings here, but most common will be 0. The data hold time is how long the data will be held in the buffers before the data goes and clears to 0. So right now we have the single EPC mode, and so we can monitor the single EPC data coming from the tag. So here is my value that I have currently on the tag, and this is the EPC data. When the tag is removed, the data hold time will hold the data in here for as long as the value is set here. Currently it's set to 200 milliseconds by default, but this can be up to 5,000 milliseconds. The select memory bank is where we're going to change it so that we can read the TID in the auto read mode. A value of 1 reads the EPC in auto read mode, a value of 2 will read the TID, and a value of 3 will read the user memory. So in this video we're focusing on the TID, so we're going to use the value of 2. It is important to set the auto read write length. We know the TID of the tag is going to be 8 bytes long, so we need to set this value to 8. This does have to match the value, the byte length of the tag, and we will always know the byte length of the tag from the datasheet of whichever tag you may be using. This is hard-coded like a MAC address onto the tag. We can set a start address if we would like, but again, this is a very small. Setting a start address may not make sense because it's only 8 bytes of data. Now we're ready to send the configuration command trigger. Because we have the AL1X command ready bit high, we are ready to send a trigger, and this is going to configure the DTI over the IO-Link master. We'll see the command's busy bit has gone high, and when the configuration command's done bit is true, we will see that our configuration has been set. We can monitor the configuration response buffer, and we can see that our data has been set. The first set of zeros here is all the write commands that we have set. If there are values other than 0, that means that there has been an error. So we can see we have no errors here, and then we start reading all the information back. So all of our configuration here has been read back, and you can see the value of matches 15, 16, 128, all the way down to the 8 and 0. So we can verify from the PLC that we have configured our DTI correctly. This configuration can be changed at any time. For instance, if I want to read the TID and I'm good for that, and now I need to change it to read the EPC, I can change this on the fly and trigger it again, and we'll see my value turns to a 1 here. So let's set it back to read the TID. And now we'll need to change our antenna mode to a value of 1 to set it to auto read mode. We now see our auto read mode is true. We're auto reading the TID. This was set back at our configuration because this was a value of 2. And now we can see our auto read write has been done. Notice I have not taken the tag away from the reader. It doesn't matter when you do these steps with the tag present or if it is not present. Any changes in the add-on instruction will be accepted. If we monitor now the auto read buffer, we can see our TID data. Here is our 8 bytes of data, so from data 0 to data 7, and now we have our 8 bytes of data. As we remove the tag, it holds it in for the 200 milliseconds and clears to 0. So this is cyclic data now. Each time I take the tag away, the auto read write done bit goes false when it's away. When the data has been updated on the reader, it will go true. So this is your indication that the data has been updated in the buffer. So now we have successfully read the TID of the tag. This add-on instruction does have other functions in the auto read mode. We can read the EPC. We can also write the EPC or the user memory, and we can do that with other functions and setting the antenna modes. These are covered in other videos.